How do I solve these questions which require you to use scalars, multipliers, or just, multiply something with something? Well, first we need to know what does this expression mean. This means that if we have a vector OE and if we scale it by some constant k, by some scalar k, then we will get to f. This also tells us that OF and OE are parallel to each other. OE is a multiple of OF. These are the two things we need to know about this. Now the question is, f is a point on BC such that OF is equals to KOE. Find BF to FC. We need to find the ratio between this and this. Now we first need to find OF so that we can get to BF and CF. Well, to find OF, we know one that it is KOE. Next, we need to find some other thing, some other vector, which when we scale it by some constant multiplier m, we can get to f. That answer is, if we multiply the vector BC by some constant m, you will get BF. Why? Because if we see BF is parallel to BC, this point, so we can use this. But there's one problem. We start at B. We need here it starts at O. To fix this, we just simply add the vector path up to B from origin, which is simply like this. And the final thing, we know these two will end up at the same thing, so we just equate them like that. Simple. KOE is equal to OB plus MBC. So let's have a recap. When we want to find the position vector of some point, and it is, and we need to use scaling vectors to do so, parallel vectors to do so. How do you do it? Well, one, it will always have one vector which is parallel to it immediately. Second, it will have another vector which first we need to have a path to it from the origin. Then we can scale this vector up to that point or down to that point. That's the two things we need to know. So we need a constant and two variables in this. Let's actually find OF then. Now we know OE is equals to negative 2b negative a half a. That's already said here. OB is equals to b and BC is equals to a. Why? Because this is a parallelogram and both sides are parallelogram plus EM. MA. Okay, let's start it like that. Now how do we solve this? We can equate the B components and the A components. The B components will give us negative 2b k is equals to b. A components will give us negative a half a ka is equals to ma. Now if we see this, we cannot solve this. Why? Because k depends on m and m depends on k, so this is impossible. So we skip this. We will use this. This is solvable. Why? If we divide by b, we get this, and we get k is equals to negative 1 over 2. Nice, perfect. And so if we plug this back in, this is also a definition for OF. Let's plug in k is equals to negative a half into this. So this is negative a half, negative 2b plus minus a half a b plus a quarter a. OF is equals to this. Nice, we found OF. Now questions will be only up to this point, but we want to find something else, these two. Now we know OF. You can just find FB and then reverse it, or directly B to F. Okay, so B to O and then O to F. So this is negative B plus this OF vector. So BF is equals to a quarter A. A quarter A. Next, we need to find FC. How do you go to F? How do you find FC? Well, we can just do FB plus BC. FC. FB, we found it, and BC, we also know it is A. So BFC will be 3 over 4A. Nice. And so we can then find BF to FC, which is 1, 2, 3. Done. That's our answer. Very simple.